Okay, now, welcome back. Now, we are at the stage that we just want to fill out the parameters and the models block for our fixed effect Bayesian model in a single level analysis. But however, before we just talk about the parameters and models, I have to explain that what is going to be the plan and what kind of a model that we are looking for, because in that case, it's going to be much easier to talk about the parameters block and also talk about the models itself. The thing that we just want to do is that we are just going to talk about the normalized whole brain volume to be a function, I should say, of, as they call that the F, to be a function of, let's say, about the age. And in order to just define this, we are just going to assign a distribution to the normalized whole brain volume. And we just want to say that the normalized whole brain volume can be represented as a normal distribution, which they do have a mean of, let's say, nu, and a sigma, which is going to be the measure for the dispersion. And from now on, as you have seen from the other 3 courses in the bundle of the courses which I have, you have noticed that all the thing which arrives comes to how to model for the central tendency measured. In our simple case right now, in order to model this, we say that the model nu is going to be represented as a linear format of the age. We say that it's going to be, let's say, we call that as an intercept B0 plus B1 multiplied to the age itself, which it shows that it's going to be a linear model with respect to the age. As you remember from the things that we have talked, we said that B0, it's going to be interpreted as an intercept, which it means that if you imagine that, for example, the x-axis represents the age and the y-axis represents the normalized whole brain volume, when we talk about the intercepts, essentially what do we mean is this. Imagine that we say that as we just go with the age, the model represents that, I should say, straight line. The intercepts means this. It means that if this one represents the origin of our coordinate, represents the 60 years of old, and we just go to the 89 years of old, it means that the normalized whole brain volume at the age of 60 is going to be that measure. That's what is going to be represented by B0. And also, in terms of what is going to be, I should say, what is going to be for the B0, B1, you remember the B1 is going to be we are looking at, I should say, the tangent of this angle. If I call that alpha, the tangent of the alpha represents as the B1. And that's what we're going to talk about then. Now that we look at this model, we saw the model is going to be linear and we have 2 parameters. The first parameter, 3 parameters essentially, is going to be the intercepts. I'm just going to call that the first parameter. The second parameter is going to be the slope. And the third parameter essentially is going to be, I should say the sigma, the measure for the dispersion of our model. Now that we are done at this stage, I'm just going to go back to the stand files that we had and complete the model that we had. Then you saw that we have a couple of parameters. The first parameters that we talked, it was a beta. We call that beta as, I should say, the beta 1. I call that beta 1, which this one represents essentially the fixed intercept, and I can call that as a real number. And also we can talk about the beta 2, which it represents, let's call that beta 0 and call that beta 1 to be consistent with what we had in our analysis. And this is going to be the fixed slope, and this one also is going to be real. The other parameters that we saw in the model that we had, it was the sigma. I can come here and define it as going to be, I call that the sigma, which is going to be the standard deviation of the error, and we can call it, it's going to be the real number. And as what you have shown that in the previous courses which I had, for the real number, for the sigma, always we have to assign that the lower is going to be 0 because the sigma should be positive number. If you forget to do that, when you run the model, the standard model, you get into a big problem. Okay, it's going to be essentially the parameter block of a model. And also the other thing which I'm just going to do, now I'm just going to come here to define the model that we have. In order to define the model, it's going to be very easy. What I'm just going to do, I'm just going to come here for the model. I'm just come here and decide in the model that I said that. If you remember from this model, we said that the n, the normalized whole brain volume, is going to be normally distributed as what we saw that as a mu. The mu, we said that it's going to be beta naught plus beta 1 multiplied to the age. And also remember, we also had the sigma in our model. And now essentially when we are done, we have to just, what we are going to do is that we just put the I should say the semicolon there, and I'm just going to call that as the likelihood. That's what you have learned from the previous course, and a priors in that case, and I didn't specify a prior for beta naught, beta 1, and the sigma. We're just going to think that they are just going to be flat. However, when we just go to the multi-level regression analysis, we do not take the flat priors. We're going to specify a prior for each parameters that we define in our parameters block. However, before we just move on, I'm just going to come to add another block, which essentially that's an optional block. The data block, the parameters block, and the model block, they are essentially the must block that you have to incorporate into your stand model. But the other block, it depends on what you want to do later. I'm just going to call that the generated quantities. For the generated quantities, you have seen that in the previous course, that's what we just want to replicate our data sets. When we want to replicate our data sets, we just create this one. We said that, okay, we define a new object to describe our essentially replicated values. I'm just going to call that again, normalized brain, the normalized whole brain volume. However, I'm just going to call that rep to define that it's going to be replicated. And I know that it comes with a dimension of the n. But before that, I'm just going to put the rep. I'm just going to put the semicolon there. You can just define it as a real or a vector, it doesn't matter. But if you just call it as a real number, contrary to the vectors, you have to define the length in front of the object. I'm just going to call that the replicated response variable. You know that the reason that I'm just going to do this is that to measure how the model is capable to reproduce itself. And also, then I have to just, for each replicated data which I create, I have to run it in our model. That's why I'm just going to run for loop for any numbers. You can just call for n in 1 to n, the number of the total observation. I'm just going to put, I should say, these curly brackets there and write exactly what I have here. I can copy it, paste it here. However, for this one, the thing which it happens, this one has to be replaced by the rep. And also, because we are just having an iteration, it becomes beta naught, beta 1, and for the age, it has to be also with the n as what we expect. The parameters, they do not need to be iterated with. We have the sigma, beta naught, and beta 1 just being intact. Only the response variable and the predictor variables are just going to be in the for loop there. And when we are done, I do not forget to just put the semicolon there, and then we should essentially be done. And also let me just bring the other curly bracket up there. It seems that everything is fine, and we have created now at this stage 4 distinct blocks in our stand model, which is going to be the data block, the parameters block, the model with flat priors, and the generated quantities block, which is a kind of a for loop in order to see how the model is accurately able to reproduce itself. Now, at this stage, don't forget to just save your file. When we come back, we are just going to go back to the R, and over there, we are just going to run our stand model and just extract from the posteriors the parameters of our interest, which is going to be, I should say, for both beta 1 and beta 0. Okay, I can't wait to see you back in the next tutorial when we're just going to have lots of fun and interesting stuff to cover.